Hello everyone. A student came up to me with this problem from integration from 0 to pi over 2 of cosine to the fifth power of x dx. And it's a somewhat difficult problem, so I decided to share my experience and information set to everyone. So the first thing to do is if you see a degree which is 5 or which is odd per se, it's a little bit easier to do than if it's 6 or even number. If the degree is 6 here or an even number, it's a little bit more harder to do because you have to use what's called integration reduction by power reduction, or you have to use a different technique to try to solve this out. Anyway, so the first thing you have to note is that cosine squared of x plus sine squared of x is equal to 1. This is the Pythagorean theorem in trigonometric state. So first thing we're going to do is rewrite this a little bit. We always want to rewrite it a certain way. You want to take one of the cosine of x and factor it out. So it's going to be cosine fourth of x times cosine of x dx. And we know that this one is the same thing as integration. I'm not going to write the limits of integration yet. Same thing as cosine squared of x times cosine squared of x dx times cosine of x dx. We know that cosine squared of x is if you move the sine squared to the right side, whoop, there it is, it becomes 1 minus sine squared. So that's the same thing as 1 minus sine squared of x times 1 minus sine squared of x times cosine of x dx. Next thing we want to do at this stage is distribute this out. That becomes 1 minus 2 sine squared of x times, plus sine, sine squared times sine squared is sine fourth of x times cosine of x dx. We elongate it a little bit more. We're going to distribute this out, change the limits of integration on this a little bit. Let's just distribute this out. It becomes cosine of x minus 2 sine squared of x cosine of x plus sine fourth of x cosine of x dx. And now the limit of a plus b is, the integral of a plus b is the integral of a plus the integral of b. So we can actually distribute this out. Integral of cosine of x dx minus 2, we can also factor out the 2 in the front. Sine squared of x cosine of x dx plus integral of sine fourth of x cosine of x dx. Okay, and we're going to have to do this one at a time. We'll do the first one first. We're going to call this A, we're going to call this B, we're going to call this C. Okay, and since we don't have enough space, I'm going to put a little bit of okay, so let's do A first. The integral from 0 to pi over 2 of cosine of x dx. Well, first of all, let's see. We can graph this out. The cosine of x looks something like this at pi over 2. This value, pi over 2 is 1.57. I memorized that. This is 1. So it kind of looks like this and goes in and out. So this rectangle is going to be 1.57. But this area actually turns out to be exactly 1. That's a really cool proof. You can prove that if you want. Oh, let's do it right now. Well, the integral of cosine of x is equal to sine of x evaluated from 0 to pi over 2. Well, what we're going to do is, if you're not sure, take the derivative of sine, which becomes cosine. So we know we did it right. So that becomes, using the fundamental theorem of calculus part 2, sine of pi over 2 minus sine of 0. Sine of pi over 2 is 1 minus sine of 0 is 0. 1. Oh, like I said, memorize this. It's going to come out quite a bit on your AP exam. Okay.
That was easy.
Yeah, I have the easy button. I'm sorry. Most of you don't. Anyway, so that's part A. That's part A right there. Well, let's do part B now. I'm going to do it on a different piece of paper because it's going to take a little bit more space. Part B looks something like this. Minus 2 integral of sine squared of x times cosine of x dx. Okay. We're going to have to use a u substitution. We're going to let u equal this right there, sine of x. And then as soon as we take the derivative, oh, such a hard word, derivative of u, you get du. The derivative of sine of x is cosine of x dx. Whoop, there it is right there. So it becomes negative 2 times integral from 0 to pi over 2. I forgot to put the limits. Sine of x was u, so it becomes u squared. Du was cosine of x dx, so we're going to leave it like that. And we know how to do that. It's pretty simple. We add it, add 1, divided by 3, u cubed over 3. And now, we have to change the limits of integration. If you plug in 0 in here, plug in 0, what's the sign of 0? It's going to be 0. I'm going to change, use this a little bit. We're going to use pi over 2, so changing the limits of integration. Sine of pi over 2, using your unit circle, becomes 1. Right there. Sine of pi over 2 becomes 1. So we plug. An easy way to do this is same thing as factoring out 1/3. You get 1 cubed minus 0 cubed. 1 minus 0 is 1. It becomes 1/3. Times it by negative 2. You get negative 2/3. And let's do part C now. I'm going to use a different ink. C. We do this one over here, which is integral from 0 to pi over 2 of sine 4th of x cosine of x dx. Okay, let's try this one. Again, you use the u substitution as well. I'm going to use blue, so I'll take this out. I'm going to let u equal sine of x again. Then du equals cosine of x dx. There it is right there. Whoop, there it is. And so we know that the limit of integration, because we use the same u substitution, is going to be from 0 to 1. Sine of x was u, so it's going to be u to the 4th cosine of x dx, which is du. Make sure you get to know your u substitution pretty well. That becomes 1/5 u to the 5, evaluated from 0 to 1. Plug in 1/5, 1 to the 5th minus 0 to the 5th is equal to 1/5. Let's finish this up. We're going to do now a plus b plus c. That's our integration. Our a value, if I remember correctly, was 1. There it is right there. Our a value happens to be 1. Okay, and then our b value plus, where's my b value? It's negative 2/3 minus 2/3 plus 1/5. Common denominator is 15. 15 over 15 minus times it by 5. 10 over 15 plus multiply by 3. 3 over 15. 15 minus 10 is 5, plus 3 is 8 over 15. Whoop, there it is, okay? I'm going to use my calculator to confirm it with you. It's a little bit tricky on this, so make sure your mode, I was on a different mode here. It's in function mode right here. Also, you put it, if you want to put in radians, it's fine. If you want to put in degrees, it's fine. Let's go degrees this time on this. On your TI-84 Plus, press Math 9. That will get you to the integration portion from 0 to 90 degrees because we're in degree mode, right? Parentheses, sine of x, where's x right over there? And parentheses to the caret key 5. And then we use, and then we get out, and we put dx. Where's the x button? There it is. And then we put math, and the default is on fraction. We go to fraction, and we should end up with A15. Okay, let's see. Whoops, sorry, wrong problem. 90. Oh, I was supposed to be cosine 5th of x dx. So let's try that again. It's called user input error. Cosine, where is the cosine button? There it is. And then cosine 5th of x dx. And then let's try that again. No. Something seems to be wrong here. Let's go to radians then, just to make sure. I'm in the right mode. And let's try that. Press enter. Let's try that again. Instead of 90, I'm going to go to delete that. Pi divided by 2. Oh, there it is right there. It doesn't work on degree mode because of this functionality. It is A15th. There it is right there. If you can see it or not, it is A15th. Okay. All right. Good luck, everybody. Try not to do it on degree mode. Try to do it on radians mode. Thank you so much. Take care. Bye.